In this video, we will understand the science behind balancing toys. To understand why I'm able to balance the toy, we need to understand the concept of center of gravity and center of mass. Before we start with center of mass and center of gravity, let's understand mass and weight. Mass is the amount of matter contained in an object, while weight is the measure of the gravitational pull on an object. If you want to know more about mass and weight, you can check out my previous video. Now, let's move on to center of mass. The center of mass is a special and single point on an object where total mass of that object is concentrated. Do keep in mind, the method in finding the center of mass of homogeneous objects varies from heterogeneous objects. Homogeneous objects, what does that mean? Homo means same. A homogeneous object has a same and uniform composition. The centroid, the geometric center of the homogeneous object, is its center of mass. Heterogeneous objects have irregular and non-uniform composition. To find an heterogeneous object's center of mass, we need to hang it randomly from a minimum of 3 points. Here, I've taken an example of a leaf to show you how to determine center of mass. An interesting thing is that the center of mass may lie inside or outside the object. For example, a pencil has its center of mass inside it, while a banana has its center of mass outside of the object. It is located outside sometimes if the object is hollow or open-shaped. By now, I hope you understood center of mass. Now, let's dive into center of gravity. Center of gravity is a point where the whole weight of body appears. If I hold a basketball in the middle with one finger, it will balance. This is because the center of gravity is present above the finger. Gravity pulls the basketball downward with 9.8 Newton of force. However, as the finger is present below the center of gravity, the finger pushes the basketball upward with 9.8 Newton of force. Hence, it balances. But if we move the finger to the right or the left, the ball will fall as the finger is no more under the center of gravity. Hence, the gravity pulls downward, making it fall. It is very important not to get confused with center of mass and center of gravity. There is only one difference between center of mass and center of gravity, and that is, center of mass remains the same irrespective of the gravitational fields, while center of gravity changes in non-uniform gravitational field. In uniform gravitational field like surface of Earth, the center of mass and center of gravity of objects are located at the same point. In non-uniform gravitational field like space, the center of mass remains at the same point while center of gravity changes to a different point. Let's look at some examples where center of mass and center of gravity are located. This pencil's center of gravity and center of mass is located in the middle. Hence, if I hold the pencil in the middle with one finger, it will balance. Similarly, my balancing toy, which you can consider as a bird, has its center of gravity and center of mass present at the tip of its beak. Hence, if I hold the bird at the tip, it will balance. Hope you guys enjoyed this video. Till we meet again, see ya!